Question of the Week from the Naked Scientists.
Hello and welcome to Question of the Week. I'm Cameron Voisey and I've been journeying through space and time to answer this question from Muster Mark.
Since the universe is expanding and light coming across it stretches as it does so, becoming more red, what happens to the lost energy when the shorter wavelength, higher energy light toward the blue end of the spectrum is shifted into lower energy red wavelengths?
Waves are just one way in which energy can be transferred from one place to another, whether that's light waves lighting up your room or sound waves taking my voice into your ear. You may be aware that waves, like light and sound, can stretch. Listen to this for example. As the ambulance moves away from us, the siren seems to slow down, which means the sound waves appear stretched. This is the Doppler effect, and the same thing happens with light. We say that it redshifts, since the light loses energy and becomes more red. But in Mark's question, something slightly different is going on. The stretching he mentioned is because our universe is expanding. As space expands, so too does the light within it, stretching it and so losing energy. So, where does all this energy go? I spoke to Enrico Paia, a cosmologist from the University of Cambridge, to find out.
This is an excellent question, and in fact one which, in one form or another, is often a source of heated debate among practitioners. So many of us are familiar with the idea that energy is conserved. It may change from one form to another, but we know that when we add up all forms of energy, well, the grand total does not change with time.
For example, when you boil a kettle, electrical energy from your home is converted into thermal energy to heat up the water. The total energy does not change. So, what does the light's lost energy convert into then?
So the short answer to the question is that, in fact, energy is not conserved in an expanding universe such as ours, and so the energy that is lost by light as it shifts its frequency to the red simply disappears.
So the idea that energy can't be created or destroyed doesn't actually seem to apply to our universe on its biggest scales. James Ferguson, another cosmologist at the University of Cambridge, explains why.
The conservation of energy can be shown mathematically to be a consequence of assuming something called time translation invariance. This just means that we expect the laws of physics to be the same tomorrow as they were today. However, in an expanding space, the background isn't constant in time, so time translation invariance is broken and the energy conservation doesn't hold in quite the same way.
Because our universe is expanding, the universe looks different from day to day, and so too do our cosmological experiments. Standard energy conservation disappears. So the answer to Mark's question? Light does lose energy as the universe expands, but that's okay. Regular rules about not losing energy as light is stretched don't hold in our expanding universe, and instead, cosmologists can consider space-time as a whole to absorb the energy. This restores a conservation principle, but not perhaps as we knew it. Thanks to Enrico and James. Next week, we're itching to get you the answer to this question from Margaret.
Science has now identified actual nerve endings that humans and other mammals have that transmit itchy feelings to the brain. Do snakes or amphibians have these same nerve types? Have frogs been seen scratching an itch?
So, what do you think? You can email chris@thenakedscientist.com, find us on Facebook, tweet @nakedscientists, or join the debate on the forum. That's at thenakedscientist.com/forum. So until next time, goodbye.